Hello, this is Mr. Best. Welcome to section 4.1, Radian and Degree Measure. We're going to graph angles in standard position, and we're also going to introduce the term radian, which is another way to measure an angle. First thing is, what is standard position? Standard position, vertex is located at the origin. So right here you will have your vertex. The initial side is always on the positive x-axis. And your terminal side will always be the side that is rotating. We will indicate the direction that we're going from the initial to the terminal side by using an arrow from the initial to the terminal. And we typically call this angle theta. Some other Greek letters you'll see on the bottom here, alpha, beta, gamma. Those will be all ones that we start to use in the trig sections. Angles can be drawn in two different directions. Counterclockwise. If we go counterclockwise, it will be a positive angle. And if we go clockwise, it will be a negative angle. So it is important to make sure you draw which direction that terminal side is actually going. We will now introduce what a radian is. First off, to know what a radian is, we need to know what a central angle is. A central angle is a positive angle whose vertex is at the center of a circle. So then what is a radian? Well, a radian is, and we're going to measure this as 1 radian. 1 radian is the measure of a central angle that intercepts an arc equal in length to the radius of the circle. You might need to read that again. 1 radian is the measure of a central angle, so it represents the central angle that intercepts an arc equal in length to the radius of the circle. So what does that mean? Well, this angle right here is 1 radian if the arc length, which is right here, is the same as the radius of the circle. So if that's the radius, then this arc also represents that same distance. So when the radius of the circle and the arc length are the same, that central angle is what we call 1 radian. So now that we know what 1 radian represents, what does an entire rotation represent in terms of its central angle? So we know this represents 1 radian when the radius and the arc length are the same, but what happens if we take a full rotation around? What does that central angle represent? Well, the way we're going to set this up is as a ratio. We're going to do the central angle over the arc length. So we'll do the central angle first of the 1 radian. So we have 1 radian over the arc length r is equal to, what we're trying to figure out is what's that central angle of a full rotation. So we're just going to call it theta over the arc length of an entire circle. Well, what's the arc length of a circle? Well, that just represents the circumference of the circle. So circumference is 2 pi r. If we now go ahead and cross multiply, we'll get r times theta is equal to 1 radian, or 1 times 2 pi r. And so if we solve for theta, we divide by r, and we get that the central angle of a full rotation is 2 pi. So what that means is, once again, from the standard position, the initial side, all the way around back to that same initial side, has a central angle of 2 pi radians. So 2 pi radians is 1 full rotation, which is the same as 360 degrees. If you cut that in half and divide by 2, then half a circle, or pi radians, would represent 180 degrees. So we'll now attempt to basically take the circle and cut it up into different sections to represent different angle measures in terms of degrees and radians. So now that we know what a radian is, are we able to take a circle and cut it up into specific angles that we'll be working on throughout the year? Some of those angles that we should know is the 180 degrees, which we already talked about, is pi. A full rotation is 2 pi radians, same location as 0 radians. And so can you take that and start breaking up into different parts? So these angles in terms of degrees, we have 30 degrees, 45 degrees, 60 degrees, 90 degrees. And then you see that those same three angles happen in each quadrant. So you got 30, 60, 90. This would be 120 degrees. This would be 135 degrees. And then 150 degrees. And then you're back at the 180. And then you would do the same in quadrants 3 and 4. Can you take that idea and then now break them up into radians? So in terms of radians, well, we know that half a circle is pi. 90 is half of 180. So half of pi is pi over 2. 45 is half of 90. So what's half of 1/2 or half of pi over 2? That would be pi over 4. It's a fourth of 180. What is 30? How much of 30 is of 180? What fraction is that? 30 is 1/6. 30 times 6 is 180. So 30 is a sixth of 180, so it's a sixth of pi. And you can do that with all these. 60 is how much of 180? Fraction-wise. It's a third, so it's a third of pi. So we'll continue to look at these angles and talk about and discuss what each of these represents, but maybe you can do the rest of them, and if not, we'll continue to talk about it as we progress forward. So on example 1, I want you to draw these angles. Now we always start with our initial side, so we're always going to start here on the positive x-axis, and then our terminal side is the one that rotates. Well, pi over 3 radians. We know that this is pi. So pi over 3 is a third, 1/3 of that. Well, what's 1/3 of that? So that's approximately that. We got a half. This is a half. So 1/3 would be approximately right here. And then you indicate the direction that you're going and you label pi over 3 radians. And the abbreviation for radians is RAD. B is negative 5 pi over 6. So now it's just the direction. Negative 5 pi over 6. So we still have pi if we go in the negative direction. That represents negative pi also. So we want to go in the negative direction. 5/6 of pi. So what would 5/6 of pi represent? Well, pi would be half of a circle. So 5 pi, or not 5 pi, sorry, 5/6 pi would be somewhere over there. That's about a sixth in terms of a half a circle. So 5 pi over 6, it's in the negative direction. So from the initial to the terminal, and that would be negative 5 pi over 6. So we're just kind of sketching these. They don't need to be obviously exact, but they need to be in the right location. On C, it's 3 pi over 2 radians. So once again, we start at 0. We have our initial side, always on the positive x-axis, and we need to go 3 pi over 2. 1 and 1/2 is basically what that's saying. 1 and 1/2. Well, 1 is pi. A full rotation is 2 pi. So where's 1 1/2? Right down here on the negative y-axis. So this in the positive direction would be 3 pi over 2 radians. So coterminal angles are angles in standard position with the same initial side and terminal side. Same initial and terminal. Well, how does that work then? If they have the same initial and same terminal, how can we have different angles? Well, remember, your initial side will always be here. And then let's put your terminal side, let's go ahead and put it in quadrant 2, say. So if we go in the positive direction, that's one angle. Same initial, same terminal, but if I go in the opposite direction, that's a different angle. So coterminal angles are in standard position with the same initial and same terminal side. And you can also go even more. You can actually go and rotate more. You could rotate more than 360 degrees or more than 2 pi, and that would create another angle. There's a lot of different angles that have the same initial and same terminal side. So let's take a look at example 2. Name 2 coterminal angles, one positive and one negative for the angle 5 pi over 6. So we did 5 pi over 6 earlier. It was negative, so we'll do the positive one. So all that means is we'll be going in the positive direction now. So we said that was somewhere over here. If this is pi, that's about 5/6 of that. So this right here would represent 5 pi over 6. What are the two other angles? Well, what we can do is we can go in the other direction to figure out that angle. Or we could once again take this and go all the way around to figure out another positive angle. So how can we do that, I guess, mathematically? Show that? Well, we can take 5 pi over 6, and what are we doing? We're subtracting a full rotation. What's a full rotation? 2 pi. And we'll also take 5 pi over 6 and add a full rotation, which is 2 pi. So you have to find a common denominator and figure out what those two angles will represent. So this would be 5 pi over 6 minus 12 pi over 6. So it looks like we at negative 7 pi over 6 would be the one right here. And then if we add 2 pi, that's 5 pi over 6 plus 12 pi over 6. So that's 17 pi over 6. And then that one would represent, here's 5 pi over 6, and then we added a full rotation to get 17 pi over 6. So those are coterminal angles. 5 pi over 6, negative 7 pi over 6, 17 pi over 6. All three angles have the same initial and same terminal side. Complementary and supplementary angles, if you remember from geometry, complementary angles are two positive angles whose sum is 90 degrees. We're going to work on radians more in trigonometry, so whose sum is pi over 2. Supplementary angles are two positive angles whose sum is pi. Once again, remember that's 180 degrees. So the pi over 2 radians is equivalent to 90 degrees, and the pi radians is equivalent to 180 degrees. So there's your complementary and supplementary angles. So find the complement and supplement of 6 pi over 7, if possible. Well, if this is, if the complement is 90 degrees or pi over 2, then we should be able to take pi over 2 and subtract 6 pi over 7 to figure out what its complement is. We should also be able to take pi and subtract 6 pi over 7 to figure out what its supplement is. So you will have to find common denominators and figure out what those two angles are. So let's go ahead and do that. So I went and found a common denominator of 14, and that gave me 7 pi over 14 minus 12 pi over 14. Subtracted those and got negative 5 pi over 14. So two positive angles. So this one does not have a complement. On the supplement, I found 7 as its common denominator, 7 pi over 7 minus 6 pi over 7 to get pi over 7. So pi over 7 would be the supplement, but we do not have a complement on this one. So moving on to the last slide here, we're going to draw each angle, but these are in degrees. So we did this earlier with radians. You should be a little bit more familiar with degrees. Remember, one full rotation is 360. A half a rotation is 180. And the last thing we'll be doing is drawing each angle that are in degrees. So we did a lot with radians. Let's go back to degrees, maybe one you're a little bit more familiar with. But we have our initial side still, and you're still breaking it up into your degrees. You know a half a rotation is 180. You know a full rotation is 360. So where does 45 degrees fall? Well, 90 degrees would be a quarter of 360, and then 45 would be half of that 90. So this angle represents 45 degrees. What about negative 270? Once again, your initial. Negative is the direction you're going, so we have negative 90 degrees, negative 180 degrees, and negative, if you add 90 to 180, that's negative 270. So here's your terminal, and you're rotating in the negative direction. So that's negative 270 degrees, and you have to label that as degrees. 390. Now 390, a full rotation is 360. So here's my initial. If I go all the way around, that's 360. So where does the 390 fall? Well, it's 30 more than the 360. So you have to indicate from your initial side all the way around one full rotation and then 30 more degrees to your terminal. So this angle is 390 degrees.